So let's recall Pascal's identity. That says that the binomial coefficient n choose k is the same as n minus 1 choose k plus n minus 1 choose k minus 1. Okay. So in a separate video we proved this for using a bijective argument by considering the sizes of various sets. But in this video we're going to just give a completely algebraic argument from the definition of binomial coefficients in terms of factorials. So let's recall how that works. So remember, the binomial coefficient n choose k is just the same as n factorial over k factorial times n minus k factorial. Okay, so let's remember about k factorial. Okay, so k factorial, that means k times k minus 1 times k minus 2, all the numbers down to 1. Okay, and then we want to notice that if we look at all these terms here, the n terms here, this is the same as k minus 1 factorial. Okay, so we can say that k factorial is the same as k times k minus 1 factorial. And then we can rearrange this if we want to say that k over k factorial is the same as 1 over k minus 1 factorial. And that was for k, but that works the same way for n minus k, of course. So n minus k factorial, that we can write as as n minus k times n minus k minus 1 factorial. And so we get the same kind of fractional thing, that if we have n minus k over n minus k factorial, just rearranging this equation on the left, what we get is 1 over n minus k minus 1 factorial. Okay, and then also we get n factorial in exactly the same way. That's n times n minus 1 factorial. And it's convenient to do a slightly different thing here. So this n of course is the same as n minus k plus k. So we can write that as n minus k times n minus 1 factorial plus k times n minus 1 factorial. Okay, so now we're basically done. Okay, so we'll go back. We'll now go back up to here. Okay, so writing out this, putting in this equation here for the n factorial there. So what we get here now is this first thing, n minus k times n minus 1 factorial divided by k factorial n minus k factorial. Okay, so here we've just used this equation here. Let's maybe label these. Call this A, this line here B, and this line here C. Then here what we're and using this equation C here, what we've got is that plus C or K times n minus 1 factorial over k factorial n minus k factorial. Okay. But now we can do some kind of cancellation. Here you see we've got an n minus k on the top, n minus k factorial on the bottom, so we can use this equation here on line B, okay, to simplify this first term. It just becomes n minus 1 factorial here, and then the n minus k over n minus k factorial, and that becomes k factorial n minus k minus 1 factorial. And we do the same kind of thing over here using this equation A. We had k over k factorial is 1 over k minus 1 factorial. That's what's going on with this term here. So then we get an n minus 1 factorial here over this. Now we've got a so we're cancelling here. So this becomes a k minus 1 factorial and n minus k factorial. Okay. Okay, and following on from here, okay, so what's this first term here? That's kind of obviously n minus 1 choose k. And then here, what we do need to just kind of, I want to say that this is the same as n minus 1 choose k minus 1. Let's actually just write that down. So why is this the same thing? Well, notice, of course, that here we should have n minus 1 factorial divided by k minus 1 factorial, and then the second factor on the bottom is n minus 1 minus k minus 1 factorial, but n minus 1 minus k minus 1 is the same as n minus k. So that completes our proof.